Awesome. Hi, welcome everybody. We're so glad that you could join us here. Whether it's afternoon or evening, or for some of you, maybe even the middle of the night, you are here for the ASE Concrete Canoe Competition Concrete Mix Design webinar in office hours. We're basically going to provide a brief tutorial for you and then open the floor for questions. So you should be able to learn a lot about um, mixed design and maybe get some pointers for your project here this year. My name is Leslie Payne. I'm the Director of Student and Younger Member Programs, and I work at ASE headquarters. We are being joined here tonight by Mike Carnival, who works for Mazer Consulting in New Jersey. And then we also have a couple other Concrete Canoe Committee representatives here. We've got Kyle Riding, who's a professor at the University of Florida, Katie Swank, who's a corresponding member, and Andrew Brunton, the chair of the Concrete Canoe Rules Committee this year. I just wanted to run through a couple housekeeping items. One, of course, is let's make sure we maximize our internet connection by leaving microphones and cameras off. You can certainly turn your camera back on when we ask questions at the end of the presentation. This is recorded, so we will make sure that we release the link for the recording afterwards. And if you knew somebody that wanted to come and wasn't able to make it here tonight, they'll be able to get the recording and watch the webinar as well. I think that's probably it. Be sure to kind of write down your questions. You can certainly put them in chat, but we'll probably just wait until the office hours at the end before we answer the questions. And with that, Mike Carnival, you want to take it away for us?
Sure. Thank you, Leslie.
You bet.
So as you well know, beginning of June, Louisiana Tech will be the host for the society-wide competition. This presentation is a rehash, basically, of the presentation that we gave last year in regards to assisting the students with mixture design. But the goal also here is to answer any questions that we could possibly do within a reasonable time frame to help you along in getting your mixed designs done and actually done correctly. We will post some of these questions to the RFI page, and if we don't address them this evening, we can address them as RFIs. So some of our sponsors for the competition have signed up already, obviously ASE Foundation and 3M, who are one of the major suppliers of some of the products that are used in the concrete canoe competition. So the first poll that we have here, and we have only two of them, is just to get a handle of where everyone is from this evening or this morning, depending on where you're at. So if we can get that up and fill out the region, and we'll take about 15 seconds to do that, and then we'll post the answer.
I think we might have everybody.
All right. So it looks like we have a good mixture throughout the country. Let's see, got to scroll down a little bit to see. No one from Region 10, but it looks like Region 9 is the winner. So I would put us out west. Great, thank you. The next poll that we actually have is basically one about the quality assurance that the teams do in regards to their mixed design calculations. So here we're basically asking, do you just have team members review your calculations? Is it more of a professor, faculty advisor? Is it an outside entity like a practicing engineer? And obviously, we have a question of, do you actually have to do quality assurance? So at this time, take another 15 seconds, and if we could fill that out.
All right, I think that's everybody.
Okay, so at least it appears that folks do, for the most part, have someone at least look at their calculations, with the majority being that another student does it. One of the recommendations we actually give is to actually have someone outside of the team. I'm making the assumption that it's a team member that is doing the review, but one of the major recommendations that we generally make is to actually have someone outside of the program take a look at it, so they can give you a third-party independent assessment of the calculations, to make sure that they actually make sense, and they can question you to make sure that you understand what's going on with your mixed design. So with that being said, we'll go on to our agenda. Again, similar to what we did last year, if you attended. We'll go quickly about the mixture development. And obviously last year, the mixed designs were all theoretical. There was no need or actual requirement to actually make a mixed design. Given the COVID requirements, we understood that you couldn't go into the laboratory and get your hands dirty to actually make a mix. That would cover the mixture portion process. We'll go over the competition requirements based off the 2022 RFP. We'll discuss the mixed design table that needs to be filled out. One of the things that we do want to go over are the common errors that we generally see in the mixed design table with some examples. We'll also go over the measured versus theoretical density, which is one of the major errors that we see in the mixed design table. We'll go over an example calculation, helpful hints, and question and answer period afterwards, the actual office hours. So you can actually post your questions in the chat, and we will address those at the very end to the best of our ability. So in terms of the mixture development, you want to specify your mix, design the mix, and then proportion the mix. So this is just a general schematic in regards to that. So your inputs are, the parameters that you're seeking to achieve, whether it's a strength, the constructability, what kind of slump, or other parameters that you want, workability, aggregate size, air entrainment, the durability, and the structural and mechanical properties come from the mixtures that are being implemented. And then at the end, your output is generally, what is your air void, the type of cement, the water cement ratio, is a good mix, is it a weak mix? And also some of the physical parameters could be the compressive strength, modulus of rupture, or Young's modulus of concrete, depending on what you need in regards to your design parameters that you're targeting. The process can come generally from literature, whether it's a review of past mixed designs or looking into the textbooks online to figure out what properties you want, the constraints that you have, which are generated by the rules and regulations, obviously, the characteristics that you want, whether or not you want a mix that is below the unit weight of water or has a particular strength. Your past experience in making these mixed designs with the materials, whether it's a local shale, expanded shale or slate, or some more of the exotic materials, your general cenospheres and microspheres. And then doing your trial mix proportions. Basically, obviously, you're looking at your admixtures, your pozzolans, and your cement. What type of cement you want: type 1, type 3, type 5. Is it air and train cement? Your pozzolans or your supplemental cementitious materials. That's your slags and your fly ashes and metakaolins and all that good stuff. The water content and your water cement ratio. Your coarse and fine aggregates. Now, obviously, with the canoe competition, most of your materials fall underneath the fine aggregate content just because of the constraints that you're putting onto your thickness of your hull. So of course, aggregate may not be generally used in the true sense of the word for the mixed designs that you have. Obviously, your air contents, and then your admixtures, your water reducers, your superplasticizers, viscosity modifying admixtures, and the like. So this is a guide to mixture proportioning, ACI 211. And basically, this is from the theoretical standpoint of how you're trying to do it, rather than just going right into the lab and just throwing, cement, water, and some aggregate together and just seeing what kind of numbers you come up with. You want to generally look at what your required strength is, select the water cement ratio, take a look at the aggregate sources that you're looking at with a true understanding of the properties of that aggregate, its absorption, specific gravity, dry, bulk, and saturated, desired air content within reason, your workability or slump aspects. Do you want this to be a stiff mix with basically no slump, or do you want a self-consolidating concrete that looks like pancake batter? Your water content, which would obviously come from your water cementitious material ratio, the type of cementitious materials that you want and their effects on strength and unit weight, and then the admixtures, which help you get your desired physical properties, workability, and such. You want to take a look at what kind of content of cementitious materials you want. What kind of proportion do you want? Do you want to have like maybe a 50-50 mix of cement and then pozzolans, or do you want to make it more heavy on the pozzolans? Step 10 goes into selecting your fine aggregate with its finest modulus. Step 11 also covers the absorption correction for the amount of water that you have stock versus what the parameters should be, in the field. And sometimes folks don't really truly understand the absorption. Basically, the absorption is a measured moisture content to get to the saturated surface dry condition. So if you have excess water, that becomes damp or wet. You could have some moisture, but it's not saturated surface dry, so that's air dry. And then you also have your oven dry mix, which absolutely has no moisture in it whatsoever. With these, there are different specific gravities. So knowing which specific gravity you have and the absorption is key in doing your mix designs. And then your trial batches, basically coming up with a design, making it in the lab, showing reproducibility, tweaking it when necessary. And then once it's done, making sure that you can go back and make the necessary changes in your calculations for your proportioning that you would present in your report. We'll go over now the requirements for the 2022 competition. Somewhat similar to last year, which or even the previous year, basically, where we are limiting you to 3 mixtures, 3 total mixtures, whatever you're using it for. Some teams like to do a, coating mix. Others like to have like a internal concrete mix and then an external concrete mix. But basically, you're allowed a total of 3 mixtures. Now, this has nothing to do with the color. So if you had 2 mixtures, or let's say you had 1 mixture with 3 different colors, everything else is the same: water cement ratio, the cement content, your aggregate content, your aggregate proportioning. That mix is a single mix. You can have it in a multitude of colors. So the 3 mixes are, if they are distinct changes within the material properties. So you have your cementitious material content, your supplemental cementitious materials, and pozzolans, and they follow basically the ASTM standards, which are listed here. These are all in Exhibit 5 of the RFP. Your fibers should meet C1116. That will cover a variety of fibers, natural fibers. We've seen teams use horsehair as an example. This covers your PVAs, your polyvinyl alcohol, nylon, and other aggregates, recycled carpets, as well as your steel fibers if you wish to use those. The admixtures are covered here. That basically covers a multitude of admixtures, water reducing, super plasticizers, set controlling admixtures. They fall under C494. Your air and training admixtures under C260, and also covers your pigments and curing compounds, which fall under 979. So these rules are fairly similar to, or that these rules are similar to last year. So the total aggregate volume has to be at least a minimum of 30% of the total volume of your concrete mixture. 50% of that must be a lightweight aggregate meets C330, which means it's certified to meet C330. Those are typically your expanded slate shales and clays. There could be a couple others. So your stave lights, your ute lights, your norlites, your sol lights. Most of those, all fall, and you can easily get the documentation that says it's C330 compliant. It can also be a recycled concrete aggregate. Basically, it's a crushed concrete source that is used, or a combination of the two. And then that way, so half of your aggregate volume has to meet these requirements. We are bringing back the microspheres and your cenospheres, so they are allowed to be used. We're also bringing back the term the mineral fillers. So if you have an aggregate source, and sorry for the typo here, but if the portion passes your number 200 sieve, so from if you want to look at it from an aggregate standpoint or a geotechnical standpoint, those are the materials that fall basically under a silt or clay size particle, very, very fine. That aggregate source, whatever passes the number 200 sieve, is not considered part of the aggregate above. It's considered a mineral filler. So you're allowed to use it, but you just can't count it toward your percentages with a 30% total or 50% of the requirements for C330 or the RCA. So this is the dreaded mixed design table within the 2022 request for proposals, very similar to previous years. Almost exactly the same as last year. The only noted difference is on the very, very bottom. you'll see that there's a C330 plus RCA ratio calculation. And that's just basically your percentage that has to be equal to or greater than 50%. So this is more of a blow up of the top half of that cementitious, or I'm sorry, of the mixed design table. Basically, you would indicate your specific gravities, your volumes, and the amount of cementitious materials that you have. This also covers the CSMs and any pozzolans that you may have. The fibers, your aggregates, excluding those passing the number 200 sieve. You also indicate whether or not it's doesn't meet the requirements of C330 or RCA. You give your percentage of absorption, and you indicate your oven dried and saturated surface dry specific gravities, your base quantities, and the volume of your aggregate in the saturated surface dry condition. You also list your liquid admixtures, and we're going to go over the calculations for those. The dosage, how many pounds per gallon of that material you're using, the percent solids, and it will determine the amount of water that you actually have within your liquid admixtures that could be used towards hydrating the cement in your mixture. Sorry, the bottom half covers the solids, which include any solid dyes, powder mixtures, powdered admixtures, and mineral fillers. This is basically similar to the calculations that you used to put your cementitious materials in terms of knowing the specific gravities, and you can determine the volumes and the amounts based off your actual mix design. The water content covers, your water cementitious material ratio, your water cement ratio, and then the amount of water that you're adding. There are several sources of water that could be attributed to get your total water. That could be water coming from your admixtures, any free water that comes from your aggregate sources. And again, that makes the assumption that, if you have excess water, that means that you are above the saturated surface dry condition. And then any batch water, basically any water from the spigot or whatever that, you need to use to attain the amount of water that you need to hydrate your cement and other cementitious materials. The very bottom covers the densities, the air contents, any particular ratios, and the slump. So you would indicate the masses, your absolute volumes, you total them up. And then from there, that's where you get your theoretical density. Your measured density is obviously what you measured or what you weighed in the lab. Your ratios include the total aggregate volume, which has to be greater than 30%. The ratio for your recycled concrete and C330 has to be greater than 50%. The slump flow, slump or spread, that's actually a measured value that you have following the applicable standards. That's generally given in inches usually to the standard of plus or minus a quarter inch. And you will also notice that there are two air content calculations. You need to calculate both. The answer should be the same. One is, if you look at the equations, you could derive one from the other, knowing what the definitions of theoretical and measured densities are. So generally, one of the errors that we'll always see is that we'll see, teams provide two air contents. Well, that should not happen. That shows that there's actual error in your calculation someplace in your mix design. But we also see some teams, they try to be sneaky and they'll just report the one, say, oh, it's just an air content. So we'll just give you the one. We want you to actually calculate both to prove to yourself that you actually did it correctly. And we'll go over that example shortly. So one of the things that we generally find that teams have an issue with is the difference between a measured and theoretical density. So the main issue is that a measured density must be less than the theoretical density. One, because one, it has a smaller volume. So your masses are the same, but the volume that they occupy are different. So in a general, whether it's a cubic foot, cubic yard, it really doesn't matter. But basically, the total volume of a concrete mix includes the aggregate, the water that's associated with it to get to the saturated surface dry condition, all your cementitious materials, the water that is used to hydrate those cementitious materials, fibers, technically your admixtures get mixed in, and then there's an air content. That will give you your measured density. That's how you figure that out. A theoretical density does not account for air. So you still have the same weight, but your volume is less. So your theoretical density must be greater than your measured density. And a lot of times we'll see just the opposite. That gives you an error as well that we generally see. So this is just a visual representation of what that is. So if I had 100 pounds of concrete, if it occupied 27 cubic feet, or I'm sorry, 1 cubic foot, that's 100 pounds per cubic foot. If there's an air content, say 10%, then your volume is now 0.9 cubic feet. So that turns out to be about 111 pounds per cubic foot. So therefore, the theoretical density is 111 PCF, where your measured density is 100 PCF. Same volume, same weight, same mass, but a totally different volume. So that's how we figure those numbers out. So the common errors, and this is basically to give you a useful guide about your mix designs. Teams need to have a good understanding of what the true specific gravity and absorption values are for their particular aggregates. The absorption, again, is by definition the moisture content to get a specimen or a aggregate to its saturated surface dry condition. A lot of times teams are reporting what the manufacturer provides. Sometimes the manufacturer just gives you a specific gravity. They'll just say, it's 1.6. They don't tell you whether it's 1.6 wet, 1.6 dry, or such. So, you got to make sure that you're getting the information that you need. Also, while it's fairly easy with the ASTM standards to determine absorption values for, say, like a shale or sand and such, it's really difficult. It is difficult for the cenospheres and the microspheres. It's problematic because most of that stuff generally tends to float. Also, the standards usually are for 24 hours of soaking. In some aggregates, you're required to do it for 72 hours. So you may want to look up some information on the web, textbooks, or by the manufacturers to figure out whether or not you have the correct absorption values for your aggregates. Again, the measured density is reportedly greater than the theoretical density. We just went over that aspect, which leads generally to a negative air content, which is actually physically impossible to have without violating the rules of thermodynamics. Air contents that don't match up. Again, that's where the two calculations are shown for air contents. One, teams will get two different numbers, and that's not possible or shouldn't be possible. Sometimes we see that the added values don't match up with the mix designs. We get volumes greater than 1 cubic yard or 27 cubic feet. We've seen teams use the incorrect table. I mean, we've seen teams use tables from like 6 years ago, and it was totally different. We're not sure why that occurs, other than they're just provided the wrong one and they just think that's the one they're supposed to use. But obviously this table is, different than all others. If you just pull it from the website, everything is fine. We have also seen teams incorrectly modify the table. For example, removing that second error content, whether they do it on purpose to hide the fact that the numbers didn't come out right, or they just made a innocent mistake, like, hey, we really don't need this because we just don't need to show it. But we've seen other things occur. But generally, you can modify the table, whether or not if you need to add extra lines for admixtures or extra lines for your cementitious materials, or you don't have as many aggregates and you want to remove a line, those types of things you can do to try to fit it onto one page. But you really can't go and remove calculations and the like just because you just don't want to report it. Now, this isn't a common error, but it's one of the things that we think teams generally tend not to do correctly, is understanding what relative yield is. Relative yield is a ratio that basically compares the volume of concrete that was made to the design volume that you thought you're going to make. And it can be reduced down to a measured unit weight divided by the design unit weight. So what happens is a team may be trying to make a 100-pound per cubic foot mix. When they do it, they end up with a particular mix design. They say, okay, this needs 500 pounds of cement, or 1,000 pounds of aggregate. When they do that, and then they actually make the mix in the field or in the lab, they'll come back out and they're like, okay, well, I measured a unit weight of like 103 pounds per cubic foot or 98 pounds per cubic foot. It's not 100 pounds for whatever reason. And you do enough to sit there and say, I can reproduce this over and over again. And at that point, you're like, okay, I need to adjust my values of my mix design. So it is a ratio. So if I had, say, 103 pounds per cubic foot mix, but I thought it was going to be 100 pounds per cubic foot, you actually made a denser mix. So therefore, the volume that you made is less than what you thought. And there's a ratio of 103 to 100 pounds per cubic foot. So that your ratio is 1.03. At that point, you need to go back to your original design and make the modification to your mix. So say you needed the 500 pounds of cement you thought was going to give you 100 pound per cubic foot mix. You actually need to divide that number by 1.03 to figure out actually how many pounds you put in to get your 103 pound per cubic foot mix. So it is a calculation, fairly simple to figure that out. But it is a common thing that we see. So a lot of times we see that the teams didn't adjust their values to represent what they actually measured in the lab. So these are common examples that we took from previous years. So disregard the last column, or I'm sorry, the last row that says EG plus C. That was from 2 years ago. But you'll see errors that we generally find, and we try to figure out what teams have done wrong. But in this particular example up top, you'll see that the theoretical density is greater than the measured density, which is correct. But the numbers that the teams provided, don't actually match up. For that, the numbers, the total numbers for the mass and volume wouldn't equal those numbers. And you'll see that there's actually two different air contents, significantly different. So obviously there is a bust in the calculations here. The one below, sort of the same thing. In this case, they actually have a measured density that is greater than the theoretical density. If that was the case, you would actually end up with a negative air content based off the air content equation that's here, which has, theoretical minus measured. So if the theoretical is less than the measured, you actually get in, you'll have a negative number in the numerator. So that number doesn't come out correctly. So these are the things where teams will, in general, they'll report a number, but it doesn't actually match up with the rest of the numbers they have in the table. An error that we see here, they have a mass with a, absolute volume for their saturated surface dry aggregate, but they end up with a volume of 31.58 cubic feet, which is greater one of 27. You should not exceed 27 cubic feet. That's 1 cubic yard. So there's an error there, which leads to other problems. I mean, obviously, again, they do have a measured density that's less than the theoretical, but part of the problem is that volume that they use, is incorrect. They shouldn't be using a 31. Here, at least, they did report a negative, air content, again, different than the second air content. So obviously there's a bust, in one of the equations here. One, you can't have a negative air content, but two, they don't match up. And same thing here on the last one. You'll see that they have two different air contents. Now, if you come up with the equation or calculation, and in one case it comes out to 12.9, in the other case it comes out to 13.1, you're probably correct. It's just a matter of significant figures or rounding or something like that from that standpoint. But when you're off by several percentage points, you should have an issue coming up there. So the example calculation that we do have is, if I believe, is exactly the one that we actually have in the RFP example. So basically, we're giving you specific gravities, we're giving you the amounts per, in terms of pounds, the water cement ratio, absorption values, and information in regards to particular admixtures. This example does not include adjusting for relative yield. This basically is saying this is your final mix design, and these are the numbers that we're using for this. Now, obviously, this is a relatively heavy mix from a concrete canoe standpoint, but it's just there for the purpose of showing you the mathematical calculations. So we use the absolute volume method, and basically it's a combination of figuring out the mass of a particular mixture, the specific gravity of that particular material, and the density of water. So these are generally used for your cementitious materials, your powdered admixtures, and the like. You can also use it for water. Obviously, specific gravity of water is 1. So you can do your volumes that way. So following these calculations, if you know the amount that you're placing in, your specific gravities, you can figure out the volume that material will occupy. And again, as we mentioned before, there are different specific gravities for different states of saturation for aggregates. The oven dry through the saturated surface dry, and those are in between, the air dry, or the damp or wet, which has excess moisture on the outside. So basically, if you stockpiled, say, a particular pumice sand, for example, and its specific gravity or I'm sorry, if it's absorption, say, I'm just throwing a number out there, 10%, but you go in and you take a spoonful of that material, you want to figure out what your or what your moisture content at a certain point in time is. You throw it in the oven, you dry it out, and say it's 15% moisture. You have excess moisture that you can account for in your mix designs. One of the things, an easy calculation, is if you know your oven dry specific gravity and you know your absorption, you can actually figure out what a saturated surface dry specific gravity should be approximately. And it is a really simple equation. Just 1 plus the absorption in percentage multiplied by the oven dry. Basically, it's the same thing if you did if you're, for those that know geotech and calculations, and you're looking at, the moisture content of a moist soil. Basically, it's the same equation. You take your dry soil and you multiply by 1 plus the moisture content at a certain point in time, you get your numbers. So that's one equation that you can use. And actually, since you're supposed to supply both of these numbers, as long as you have one, you can figure out the other. In terms of the water, we know that moisture content is, or your water cementitious ratio times the cementitious amount will give you the amount of water that you need. Again, a fairly simple equation in calculation to do. So this is the water that's going to be needed to hydrate your cementitious materials. This water here is different, is different than the water that you need for conditioning your aggregates. Water can come from your admixtures, particularly your latexes, is one of the general admixtures that you can get a lot of water from. There are some others, again, liquid dyes, and the RFP actually tells you which aggregates to avoid or not determine what the moisture content is or your water content from that particular material. So to determine your water from admixtures, you need to know the dosage of that particular admixture, your cementitious material by 100 weight, the water content of that admixture, and then there is a calculation for fluid ounces and gallons. And from there, you can figure out the amount of water from a particular admixture. Again, this is the water that could be used to hydrate your cementitious materials. If you're looking for the solids content, it is basically the same, same way of doing your moisture content, just slightly different. That instead of the water content, you're figuring out the solid content of a given admixture. So if you know one, if you can figure out the one equation, you can, and value, you can do the same for the other. So in the end, you want to summate your mass of concrete by taking all the masses of your cementitious materials, any fibers you're using, the aggregates, the water, and any solids that you have from your admixtures or mineral fillers would fall underneath this category. And you sum that up, and then you get your mass of material for your particular concrete in the units of pounds for a cubic foot. Then you want to figure out what your absolute volume is. So all your constituents. Already warn you that it should be less than 27 cubic feet, which is 1 cubic yard. If you have anything greater than 27 cubic feet, you will end up with you should technically end up with a negative air content in one of your equations. So for this example here, we're just a tad under 24 cubic feet. So now I have my mass, I have my volume. I can calculate my theoretical density, which has no air. And then I have my measured density. So if I take my mass and divide it by 27, I should be getting 99.55 pounds per cubic foot. And we went over those equations previously, the theoretical and the measured densities, what they should be and what they should come out to be. So we do a check on the air contents. So I have my theoretical density, I have my measured density, and I get 11.3%. If I do it volumetrically, I should be also getting 11.3%. And again, here, we just highlight in red, that if your measured density is greater than the theoretical density, you will get a negative air content. And again, you do need to do both calculations as a check to show that you're doing it correctly. So some of the helpful hints, I know I'm going through this fairly quickly because we do want to get to the questions. We figure that most of you already have some aspect of concrete mix design, but we're actually going to be here to help you even if you have minimal experience. You want to make sure that you have the correct values for your specific gravity, absorption. Take a look at the data sheets that are being provided to you by the manufacturers. Sometimes they provide incorrect numbers, so you may want to take a look at some other sources for the same material and check. You could also take a look at old mix designs by other teams that use very similar materials. I mean, your ProRavers, your Cisospheres, your Cenospheres. A lot of teams have used numbers or the same materials over the years. You should take that with a grain of salt because some teams will have numbers all over the place for the same product. If you're having troubles, you could also contact us and say, hey, I got this material. This is the information that they have. Do you believe that this is correct, or should I be looking up some other source? We are here to help. Make sure you have the correct values for the percent solids, weights per gallon of your admixtures. Years ago, I was looking at a team, looked over their calculations. They actually were using a weight which they thought was per gallon for a particular admixture. They basically said, hey, we weighed the jug. This was the weight. So therefore they had a weight per unit, per gallon. Took a look at the container that was in, and the container was more than a gallon. So it turns out that while they had the weight, it was not 1 gallon. It was like 1.3 gallons for whatever reason. So therefore, the weight per gallon should have been different. And it was an honest mistake. They're like, oh, we assumed it came in a gallon jug, and it wasn't a gallon jug. Consider rounding your weights to the nearest pounds. A lot of times we'll see teams, say, oh, I have 937.13 pounds per cubic yard of cement. Well, is 900 close enough, or 910? Close enough from a concrete mix design? Do I need to actually have it to the, 2 or 3 decimal places? Again, when you're making mixes and you're specifying it, it's, you're trying to make it easy for those that are doing it. The mix design, again, is generally given in pounds per cubic yard. Also be given pounds per cubic foot. I mean, it's just, just multiply it by 27. So, you want to make sure that your total volume is a cubic yard. Again, the absolute volume must be less than 27 cubic feet. You want to do the air contents check the calculations. We highly recommend creating a spreadsheet to help you with your calculations. You know, set it up, maybe take some other teams' numbers and plug those numbers into your calculator to see whether or not you're getting the same values. Do several of those to make sure that you're, you know, just dummy proofing your spreadsheet. Again, we say mention, you know, using the correct table. Obviously, you know, you've been warned which table you should be using. And again, you know, the big recommendation we have is generally to have a professor or practicing engineer outside of the team review the calculations. And it shouldn't be the very last calculation you're doing. It should be somewhere along the way, because if not, you're going to be making mistakes, you know, throughout your entire process. And just, you know, give them the calculation, say, hey, here's our mix design. Here's what we came up with. Here's the proportions that we have. Does this make sense? And again, you know, you want that third party review or someone that can put independent eyes on it. You know, may not be familiar with, you know, the Canoe competition at all, but at least they understand, you know, concrete mix designs. And, you know, they generally can easily point out any mistakes that you have and then figure out ways to, you know, correct them. So with that, I greatly appreciate the time that you gave this evening. I know I sort of rushed through most of this. Again, much of the information is in the RFP itself with the example calculations. But at this point in time, we will open it up to questions, and to the best of our ability, we will attempt to answer them. If we have trouble doing so, if we have to go back, we will write these down and get clarification, but we'll try our best to answer them now if possible.
So Mike, we did have a few questions from someone in the chat. I did just put a response in, but we could kind of briefly touch on them if you want.
Is this one from Ahmed?
Yes.
All right. So he has several questions here, and we'll answer them. Can we paint the canoe with the country flags and team name? You cannot paint. You can use color concrete. You can, that's pigmented integral concrete. You can with the lettering, you're allowed to use vinyl sticky letters, but we avoid the paint, and there's a variety of reasons for that. There was years ago there were issues about stains and paints and what products could be used and not used, and it became very complicated in terms of trying to figure that out. So basically, you're not allowed to paint on any stains or paints onto the thing. So everything you gotta do, any color is a colored concrete with dyes. Second question, but you can make, if you want to make a flag out of color concrete, obviously you can. We've seen teams do a variety of things over the years, very, very colorful, very artistic ways with all color concrete. Can we use super plasticizer? Yes. Simple answer, super plasticizer, sometimes referred to as a water reducer. In some aspects, it is allowed to be used. They fall under ASTM standard. Silk fibers inside the concrete, I assume as secondary reinforcement. I would say that is more likely allowed under C 1116. If you have a particular fiber that you want to use, we would suggest that you submit that to the C4, that we could take a look at it, as long as it meets the requirements, or in our opinion, does, we can accept it. Let's see. Can we use latex in the mix? If I'm correct, latex is not allowed.
Yeah, that's right.
So the answer to that is no. Yeah, it says here graphics, paints and stains are prohibited. Could you use color concrete for using C979? The answer to that obviously is yes. We went over that.
So it looks like there were a couple more questions that had come in.
Yeah, I'm going through these.
Jack had asked about previous examples of letters of intent in preliminary project delivery schedules. I know that's something that's coming up that's supposed to be due here in the next few days, I believe. I'm not sure if we have any. I don't know if we have the previous year's reports available on Cerberus.
Yeah, I mean, we could find out whether or not and that may be just a simple opening up the folder access to last year's reports. We would have to, Eden or Leslie can answer that, whether or not we can grant
I could
access
sh-
to everyone.
I could share that access if people would like that.
Okay. We
Okay.
can, we'll post that as an RFI to the Facebook page.
Yeah, and if we're able to do that maybe tomorrow morning, since it is something that'll be, is it the 5th? Is it this Friday that I think those are due? So if we can potentially get that opened up for tomorrow, then we can post something on Facebook for everybody to have access to.
I can do that tomorrow morning.
There's a question about decorating life jackets. That should be fine. It doesn't have any
Yes.
impact to the actual canoe itself. Some teams make hats. Some teams will wear, sunglasses or matching swimsuit or matching life jackets and things like that. So definitely you can have fun with a lot of those components.
There's a question about foaming agents. I believe they are allowed. Again, we would recommend, if there is a material that you're not sure is covered, the ideal thing is to send information about the particular agent, admixture, or other material to the C4 so that we can take a look for ourselves to make sure, because there have been instances over the years where teams like, oh, we want to use this material, and it wasn't specifically meant for concrete, but they're like, well, but it meets this definition, and we're like, oh well, it may not be. Back in the day, you were allowed to put sealers on canoe, but then one team came in and said, oh, okay, well we're using this 2-part epoxy sealer, and it just, while it met the intent of while it met the letter of the law, it didn't meet the intent of the law. So we want to be careful about granting total I'm trying to think of the right word, making sure that everything is correct. So we just want to again, we recommend that you send in a particular material name. If you have a link to the website or are able to provide the PDF to us, we can take a hard look at it and tell you whether or not it's allowed. Can we put sponsors on life jackets? I'm trying to. I would say that would be allowed. I mean, you're allowed to put sponsors on t-shirts and we can't tell you not to wear a t-shirt.
Right. You wouldn't want. I don't believe you can put sponsors, directly on your canoe. And I know there's also under the display requirements, you can't have sponsor-related items as part of your display. But I don't think there would be anything that would restrict you from life jackets, say.
All right, there's a question here. How do we go about selecting how much cement and CM to use? Are there specific tables or equations to use? There are some tables that the Portland Cement Association has. A lot of this is trial and error. You could also go about taking a look at mix designs from other teams and seeing the amounts that they use. Again, I would tell you, whatever you read in those reports, take with a grain of salt. That's not to say they're always correct.
And keep in mind that the mixed designs that are in the cement contents that are recommended by the Portland Cement Association are for traditional concrete, not the super lightweight concretes being used in canoes. So trial and error and what other teams have used in the past are probably better starting off points.
Yes, and my experience, again, you can take it for what it's worth, probably cementitious contents are somewhere anywhere generally between, I would say, 450 and say maybe 900 pounds per cubic yard. It's probably generally in that type of range. But again, that's going to be depending on what kind of target unit weights and strength properties that you want.
Yeah, and as part of right now, I would assume that there's a handful or a lot of you guys that are kind of going through, coming up with your mixes and things, and creating some sort of kind of, Kyle alluded to it, is testing, trial and error. So coming up with a testing regimen that you can see how adding more cement or using different admixtures or different amounts of aggregate, how that affects your strength or other properties of your concrete could be beneficial. So, you could come up with, 10 different mixes, 12 different mixes or something like that, where you're just varying different variables within your concrete. Now, you don't necessarily maybe want to vary multiple variables at a time, because then it's hard to tell what each of those variables is doing to your mix. One might be strengthening it, one might be weakening it. So setting up some sort of testing plan for different concrete mixes and different amounts of materials could be a place for you to kind of play around with that.
There's a question here about the use of the same aggregate with different sizes. Are they considered different aggregates? So the answer is generally no. If you have an aggregate, say you have a sand, that sand can have a gradation, from 3/8 inch down to 200 sieve. I mean, that's a different particle size, but it's still considered a sand, a given sand. So in that aspect, that aggregate source is the same thing. I'm making the assumption here that maybe you're talking about the different grades of microspheres like ProRaver that have technically different properties. Specific gravity being, one of them. Sometimes the absorptions are a little bit different. In general, I personally would still say that that is a it's the same type of aggregate, the same source, even though it has slightly different properties. It's just, you know, a processed glass material with, you know, different properties. There's nothing wrong with you breaking them out per se, because I mean, you're allowed to do so. But like if you're doing like an RCA or say a Solite or, you know, a C330 aggregate, you know, it should be the same. It should still be considered the same aggregate. What would be an ideal schedule or environment for wetting concrete during curing process? Well, so if you're curing the concrete, it's like, well, what's the ideal schedule? That's really going to depend on what you want to do. Some teams will cure it for 28 days. They'll put it into, you know, they'll just cover it with a burlap and plastic. Some teams make a bathtub and soak it in lime water. You know, some teams, you know, will have mixtures that don't need to cure. It sets up so quick and you know, using the materials that they have, it's cured fairly quickly. They got the strength that they need and they're ready to rock and roll. So it really depends on the materials that you're using, you know, and your desired properties, and can you get those properties with, you know, within your curing regimen? Do I need to do it in 3 days? Do I need to do it in, you know, can I do it in 28 days? I mean, there's everything from steam curing. You can actually dry cure. You can, you know, shake on powders and, you know, put on that kind of curing agent. So it's kind of hard to sit there and tell you what it should be. You know, again, it's a function of the materials that you're using, and again, it could be trial and error. You know, you can see what other teams have done and what facilities that you have that you can do it. I mean, you know, soaking you know, obviously we know that concrete does cure best in water, but whether or not you know, do you have a tank that you can pour it in? You know, do I need to add lime? You know, is it heated? Or can I just can I get away with just like you field cure, you know, your specimens? You burlap and plastic over top of it, and, you know, break some cylinders, quality control cylinders at, you know, 3 days, 7 days, you know, 14 days. Like, okay, we're good to go. Again, that's a trial and error process as well. I believe that's all the questions I see in the chat. So at that point, we do hope that this was very very helpful to you. Again, any questions that you have, I'm personally responsible for the R5s. I do admit I fell behind for a variety of reasons. I am trying to get caught up on the questions, but you know, things have changed for me now. Work has just been astronomically difficult the last couple of weeks for me, but we're getting caught up. I do want to make sure everyone gets the information that they need and their answers. I don't have too many questions to respond to, but we'll get caught up and keep it on a pretty continual basis. I'm usually known to get answers out fairly quickly. It's just been a rough couple of weeks, so I'm still working on those to get caught up, but I think we're good to go. Do appreciate you taking some time this evening to go over this seminar. We do hope that it is very helpful, and unless there's any other announcements, Leslie, I'll turn it over to you.
Yeah, no, I can't think of anything, Mike. Just want to say thank you to you and Kyle and Andrew and Katie for coming out tonight and doing all this great work on behalf of our students. Thanks so much. And students, thanks again for coming. Good luck with your projects this year. And send in those questions to and your RFIs to Facebook. We will, or to the Concord Canoe mailbox, and we'll be sure to answer those very soon. Thanks so much. Have a great night, everyone.